Covering one small section here, a little bit left to finish up protocols and communications about moving data through the network. I'll slide out of the way here and we'll get going. So, moving data through the networks. In communicating the message, the computers break down the information, and with any kind of message. Let's say you're sending a picture of a cat to your mother. That cat is going to get broken up into lots of different pieces, the photograph will be broken up into thousands of little pieces. You'll have a paw in one and a whisker in another one, and it'll get sent across, and it'll be segmented into lots of small pieces, and then sent across the network, and then reassembled at the other side. And not only that, but your cat picture is going to be interwoven with a picture of somebody else's dog for a while. But don't worry, it's not going to look funny at the other end. They'll be separated at the other end, and all the cat pictures get put back together, and all the dog pictures get put back together, and it doesn't matter. It's just that during the communication process, it can all ride at one time. Much like putting a lot of cargo in one rail car. As long as it's in boxes, it doesn't get mixed up. So we do this with what we call protocol data units. Everything is broken down into one PDU. And we have up at the top level, there's the data. That's the picture of the cat. So it gets broken up into a segment, and the transport header is put onto it. Think of and I used to work in the airline cargo business, and if you get a big shipment of 20 or 30 boxes, you would mark them one of 30, 2 of 30, 3 of 30, so that you knew how many were coming and which one it was. That's pretty much what happens here. All the little the segments get marked as they become packets, and then they're put onto the network. And then as it goes on down, the transport header gets put on, then the network address gets put on. That's the IP address of the destination before it starts its long journey across the web. And then it's got to make it onto the physical web. So before it goes out onto your Ethernet cable or over the Wi-Fi, it has to have a framing header put on. Framing headers work at layer 2. And that frame header encapsulates the network information, and encapsulates the transport header, and encapsulates the data. So everything is tucked inside, and then the frame header can decode it into the ones and zeros that carry it along. Okay? So when it gets to the other end, all of that stuff is going to get sorted out. So when you send one whole frame, it has data inside of it to get it between one device and another on the local network. That's the MAC address. Then it's got IP information to get it from the source and destination all the way across the web. And then it has TCP, Transmission Control Protocol. That's so it can communicate back and forth. Hey, I got it, I didn't get it, resend it. And then the data, well, that's the piece of the picture that you've sent. And when you get to the other end, it all gets undone. First, the receiving computer tears off the Ethernet frame, throws it away, and looks at the IP packet and says, oh yeah, this is for me. And then it throws off the TCP, and then the TCP data, it says, yeah, I got it all, sends that message. And then it looks at the data, and then it starts reassembling it into the presentation layer to put that picture back together. All right. So at the different layers, here's what happens. At the physical layer, timing and synchronization. That's just devices talking to each other so they can understand the ones and zeros. At the data link layer, destination and source of physical addresses. Now those are the addresses on the network interface cards, the NICs, of the individual devices. And that address is only good from one device to another. So it's good from the PC to the router, and then the router, that router has a MAC address too. And then that MAC address goes away, and another MAC address goes on between another interface on the router and the ISP. And then that MAC address goes away. The MAC address will change many, many, many times between source and destination. Every hop it changes. But the IP address does not change. The source and destination logical address, the MAC address is physical. The network address is logical. That stays all the way through. And then the transport layer talks about source, did it happen, and how many and what ports does it go into, and then the upper layers sort out whatever kind of data it is with the application that you're using. So communicating with a device on the same network is much easier because you're not going through all kinds of routers. You just use the source and destination address of the Ethernet cards. They're framed. So you see you have the source and destination of, those are hexadecimal. They have, here's what an IP address looks like, 192.168.1.110, and then the hexadecimal MAC address. And we'll look at those later on. Okay? And so, the lookups can happen. The router would get that packet with the IP address and say, hey, that's my network. I'm pushing it backward right out to the MAC address here on the frame. So there is what we call an ARP request, and that's Address Resolution Protocol. That's another protocol that you can see happening in Wireshark. And that's when a server or a router or a device says, hey, I have an IP address, but I don't know a MAC address. So all the routers and switches, every device, even the PC you have now, has a table of recent communications that map the connection between MAC addresses and IP addresses. Because MAC addresses never leave the local area network. So when traffic comes in from the outside with an IP address on it, it's like, hey, wait a minute. I don't know whose MAC address this is. How do I send it locally? So that's what the ARP request is for. And then a default gateway is another term you'll configure on a computer. And that is usually, like in this example here, these users have a default gateway of R1, the interface that connects outside. So the local area network is all inside. Once it gets to the router, it's heading out to the web. And what that means is any address or any packets that the computers on the inside don't know what to do with, they have no idea where it goes, they send it to the default gateway. And the default gateway is generally a router that knows how to get outside and what to do with that message. Okay? And on a remote network, we have to go into the source and destination. Remember the MAC addresses, they change all the time. PC1 goes to R1 and then it changes out again, and then the MAC address is going to be different at the other end, but the destination address is going to be the same. The source and destination addresses will not change. That's going to come up again and again. You'll get a little bit tired of it, perhaps. So anyway, that's it for the lecture. This one's a little quicker. Good luck getting with the material and the testing, and we'll see you in class with any questions, or you can drop me an email. Thanks very much.